Welcome to my YouTube channel, Techie Sci.
Input-output ports. Okay, GPIO ports. Digital input-output ports. For example, if you want to connect LEDs, buttons, whatever it is, single input value, single bit value, that will be connected through digital input-output. That will be connected to digital input-output. Analog ADC, if it is an analog input, you need an ADC and also you need a DAC. And for communication, you require UART, SPI, I2C, and also you can use PWM, PCM, and also more. Okay, these are things that we use it with input-output ports. Timers and PWM. The main purpose is that you can generate delay and you can go for the functions pulse width modulation, motor control, and LED dimming. Okay, these are things that is used. If it is pulse width modulation, if it is with 50% duty cycle, the on period is 50% and off period is 50%. In that case, we can call it as 50% duty cycle. If on period is 75% and off period is 25%, you can call it as 75% duty cycle. If on period is 25% and off period is 75%, then the duty cycle is 25%. Interrupt controller. The basic function of interrupt controller is that it triggers the interrupt. The peripheral triggers the interrupt. Example, UART data receipt. And second thing is that nested vector interrupt control. It prioritizes and jumps to ISR. You have number of interrupts that it handles number of interrupts. Okay, in previous case, you have only one interrupt and the peripheral triggers the interrupt. In this case, you have n number of interrupts and that is handled efficiently with nested vector interrupt controller. Okay. So it is like a smart traffic cop that decides which task needs urgent attention. CPU resumes the main program. Interrupt controller. Okay. You can just see the peripherals. Input-output ports. The request that has been made to the vectors. Peripherals makes a request to NVIC. And also input-output ports that makes a request to NVIC. Okay. So the function of NVIC is that system tick is also given. Timer is also given as an input to NVIC. Okay, what it does is that it prioritizes the interrupts, whatever occurs at that moment, and that will be executed by the processor. Okay. If there is any exception occurs in the processor, that will be intimated to NVIC immediately. Okay. This is a simple function of microcontroller. The architecture that is used here is Cortex M4 processor. Bus system. AMBA, AHB, or APB. These are normal bus system that will be used. Advanced high performance bus, advanced peripheral bus, advanced microcontroller bus architecture. Okay. It will be one of the bus system. Okay. For advanced high performance bus, it is high speed. With high speed, data will be communicated between the CPU and the memory. Okay, data was communicated between CPU and memory with high speed. And main highway between CUO as well as CPU, that is CPU and the memory, is that it is fast structured and handles lot of traffic. This is the advantage of high performance bus AHP. APB, advanced peripheral bus. It is low speed. Okay, it uses UART SPA. It communicates between UART and GPIO. It is simple, not for high traffic. It is not used for high traffic. Advanced microcontroller bus architecture. Developed by ARM, it is a standard for communication between various blocks inside a system on chip, that is SoC, like the CPU, memory, and peripherals. Okay, this is a simple AMBA bus architecture. Okay, what it does is that it uses high performance ARM processor, high bandwidth on chip RAM, high bandwidth external memory interface, DMS bus master, and all this is communicated between this is bridge between bridge and high bandwidth external memory interface. All these devices are communicated through AHP or ASP. Okay. And from here, all this is low speed devices, UART, timer, keypad, PIO, everything. So here I require APB. Okay, I don't require speed here. So between this bus and this bus, I'm going to put a bridge between it. This is AMBA bus. Okay. Advanced peripheral bus. In case of advanced peripheral bus, it communicates between master and slave. It communicates between master and slave. Okay. CPU is communicated between I2C, PCI, UART, and timer. Okay. Between these three things, it communicates with APB with that of CPU. Okay. And AHP, high speed bus. In this case, I have high performance ARM processor, high bandwidth ARM chip, high bandwidth external memory DMA bus architecture, bridge, UART, SPA timer, and PIO. Now here I will use low speed bus, and here I will use high speed bus. So AHP I will use it here. Here I will use this portion, I will use AHP. Clock and power management. Clock sources. Okay. In case of clock sources, you have external crystal as well as internal as. And next thing is low power modes. It works in sleep mode, stop, standby. These are the modes it works. Now, with red color arrow mark, you can just see the clock source selection. How the clock source selection is done using how we do it. That is represented with red color arrow mark. And you do frequency scale. Okay. So now we are going to play with the clock. Either you want to change the duty cycle, divide the clocks with low frequency or high frequency, whatever you want. In that case, you can go for frequency scaling. Okay. Next is selection of processor and memory in embedded systems. Embedded systems are specialized computing systems performing dedicated functions. Selection of processor and memory is crucial for performance, power efficiency, and cost. This presentation focuses on selection criteria, types, and trade-off. Classifications of embedded system. Small scale embedded system, in that case, you will use only 8-bit microcontroller. It is not necessary that you have to go for 32-bit microcontroller or 16-bit microcontroller. For example, if it is a small toy, you can just take a toy car which moves around, which moves in the house. Once it hits the object, automatically relocates and moves in different direction. Okay. For that dedicated functionality, it is a very simple task it has to follow. For that case, you need not use 16-bit or 32-bit microcontroller. In that case, it is very better that you can go for 8-bit microcontroller, which is very cheap, and also it is cost effective. For medium scale, you can go for 32 or 16-bit microcontroller. For sophisticated systems, that is application processor, DSP, system on chip. In that case, for sophisticated systems, you can go for this type of process. That is, you require, the cost will be high, as well as it maintains the timing. That is the important, that is the advantage in case of sophisticated system. Just imagine about the airbag in sophisticated car. This is a simple example that is used in a simple example for sophisticated system. System needs dictate processor and memory choices. Processor in embedded system. A processor is the brain of the embedded system. Okay, the types of processor are microcontroller, microprocessor, DSP, and system on chip. In case of microcontroller, there are different simple microcontrollers that is available, 8051, PIC, AVR. These are the small, these are the microcontrollers that we use it in real world. In microprocessor, we use ARM Cortex. There are different ARM Cortex M. We have different things that need to be, different things you can use it in case of microprocessor. Okay. In case of DSP processor TMS320C55X, that is used in DSP processor. In case of system on chip, simple example is Raspberry Pi. It works as a mini computer. Okay. With less price, it works as mini computer. That is the advantage of Raspberry Pi. Okay. Let us discuss about the 8051 microprocessor versus PIC 8051 microprocessors versus the PIC. Okay. In this case, you can just very well see that whatever we have discussed, all this will be available here within this architecture. In case of 8051, see, you have a CPU, you have an oscillator, okay, you have interrupt controller, you have on-chip ROM, you have bus controller, you have on-chip RAM, 4 input-output ports to communicate with the outside world, okay, and then RTC, real-time clock, timer 0, timer 1, serial port. In case of serial port, you need to transmit single bit. Okay, so transmit data and receive data with single bit. That is possible here. Okay, interrupt, you have 2 interrupts, INTO and INT1. Okay, these are things that is available with 8051 microcontroller. If it is PIC, and here there are different architectures with PIC, it is 16F 8X block diagram. Okay. Just see what it does. You have a CPU, you have a ALU unit along with W register, working register. Okay. And you take the data and you take the data from RAM. You take the data from RAM. Okay. Or whatever instruction that it has to execute, it takes it from instruction register. Both is fed to the multiplexer. It is a 2x1 multiplexer. It is a 2x1 multiplexer. What it takes is that it takes an instruction register as well as the data as an input, and it feeds to the ALU. Okay. It takes W register help. Repeated computation, it does it with W register. And once the output is obtained, in that case, it passes to the input-output ports through this bus. Okay. So in this case, what it does is that you have whatever that is in ALU, you can very well see the status of ALU using status register. And you have file select register. It is an indirect address, and you have direct address register. Okay, you have both direct address register and indirect address register. This is fed, it is passed to another multiplexer. From this output, it is fed to the RAM memory. Okay. The next instruction that has to be fetched, that will be available in the program counter. Okay. So you have EEPROM, you have timer, you have input-output ports, instruction to decode and also to control, and then timing generation. That is clock out and clock in, everything you have it. You can power up your timer, oscillator you can start up. You can reset power on. You have watchdog timer also. Okay, these are the difference. These are the microcontroller architecture, and this is the difference between 8051 and PIC. Okay, microprocessor ARM. The ARM architecture, what it has is that you can just see the ALU is connected to the barrel shifter. The barrel shifter does basically, if it is a multiplier or whatever processing that you use it, you can use shift and add method for multiplication. The basic operation that we use it, or multiplication, addition, these are the basic operations that we do it for any processing. So for multiplication, we can very well use barrel shifter. Okay. And that value, you store it, that value, you take it to the register bank. Okay. So you have multiply register, you have the bus, you have bus separately for program counters. This bus is separate, this bus is separate, and this bus is separate. You can see little bit different architecture in case of ARM. DSP processor. In this case, what we do it is that program memory, instructions, and secondary data. Okay. PM data address generator, DM data address, that is DM data address generator. You have a program sequencer, you have a cache memory, you have data registers, multiplier, ALU, and shifter. Just see the buses here, that is how it is connected. This portion, it executes parallelly. That is, you can speed up the task efficiently if you use DSP processor. And you have data memory, you have input-output controller, which is connected with high-speed serial parallel ADC, DAC, etc. Okay. See, you have address bus here, you have address bus here. You have data bus here and you have data bus here. That is, you can speed up the architecture. Okay.
Thank you, friends.